Assalamu alaikum warahmatullah. My dear students, this is chapter 7, the second part of chapter 7, in which we started talking about expressions and assignments. And I'm gonna continue this chapter from this slide number 18, in which we're gonna explain the type conversions. Type conversions, which is concerned about the converting values from one data type to another data type. There is a lot of data types that some of them can be implicitly converted and some of them explicitly converted. So converted from one data type to another. If you look on the screen, you will see that we have a lot of different data types like bool data type and character, char, short, integer, unsigned integer, long, unsigned, long, and then float. The last three are floating points. Long, double, and float are three different data types on the floating point. So converting means changing a value from one data type to another data type for the sake of calculation concerning some statements in some programming languages. Type conversions can be narrowing conversion or widening conversions. Narrowing conversion means when you convert an object to a data type that cannot include all of the values of the original type. That means if you convert, for example, from a float to an integer, a floating point, that you convert a floating point value to an integer value, like for example you convert 12.5 to from float to an integer, it might end up as 12. That means smaller than the original value. That's why it is called narrowing conversion, because the value will end up less than the original value. Widening conversion, on the other hand, is the one in which an object is converted to a type that is at least approximation to all of the values of the original type. So it could be the same value or more than the value. It's called widening conversion. For example, an integer converted to a floating point. So an integer value that converted to a floating point might end up to the same value or might end up to bigger than the original value. Mixed type conversion or mixed mode conversion that has operands of different types. For example, you have an integer and character and floating point. This example here shows that I have value 12 plus a plus 11.056. Three different types. This is an integer, this is a character, and this is a floating point. So you can add them together. You might not predict the result of this expression, but it is allowable in many programming languages, including C-based languages. Coercion, on the other hand, is an implicit type conversion. Implicit type conversion, that means implicitly it is changed or converted to a type that has been declared for it. This example here, for example, x has been declared as double in C or C++, and can assign 3 to x, like saying x equal 3. This is implicitly during compilation process. The compiler will convert this 3, which is now you look at it like an integer, but it will be converted implicitly to what? To a double, since it is declared here with a data type double. Also this example here, int x equals 3.0. If you look to 3.0, you look, this is a floating point value, right? Floating point value, because it has a decimal like 3.0. But because you declared it as an integer here, int equal x, so during compilation process, the compiler will automatically convert this 3.0 to 3. That means it will change it to an integer from this value, which is a floating point value, to an integer value, which is just 3. The disadvantage of this coercion, this is called coercion. Coercion is an implicit type conversion. So the disadvantage is ability for the compiler to detect the error, which is decrease in the ability of this compiler for tracing the errors in the programming. So because you look at it and then you know that it is implicitly done, but for programmers with little or no experience, they might have some concerns about the appearance of these values in the code like this, and they might expect that this might create an error, but in fact it does not create an error, because the compiler will implicitly convert that value to the value in which the data type has been specified during declaration. In most languages, all numeric types are coerced in expressions using widening conversion. That means the data type more likely will be converted to a value that is approximation. In approximation, it is the same value or more than the value, rather than narrowing conversion. One of the type conversion is called explicit conversion. Explicit conversion, like casting or typecasting in C and C++, it is one of the examples that can be called or considered as explicit type conversion. Like, for example, you change a value from its data type to another. This angle maybe has been declared as floating point, but if you put int before it here in C programming language, then you will change it to an integer. In F#, if this sum is declared as an integer, for example, then you can convert it to a float by putting the data type float before it. Let me consider as example here for casting. This, for example, value in C++, this value number 2 has been declared as double with 9.98. But here, when I display it, of course I can display it like that. Here it is, which is 9.98. No problem with that. But if I put int before it here, before this value, that means I'm converting 9.98 to an integer. So what is going to happen? What is going to happen is going to actually display it as 9 only, which is, it is an integer, converting it from a floating point, from a double, which is a floating point, into an integer, which is going to be just an integer on this. So this is one example for casting, which is explicit type conversion. Sometimes there will be errors in expressions. These errors can be caused by some arithmetical limitations, or sometimes limitation of computer arithmetical ability to provide all the memory location for the output, like overflow. In limitation of arithmetic, like division by zero. Division by zero sometimes creates an error because you cannot divide by zero. So this example here, for example, you divide 10 by 0. So what are you expecting if you divide 10 by 0? Now, if you run it, you might expect nothing. Nothing has been displayed, or this after process it returns a value of this, which is, we call it in programming, garbage, a value that has no any meaning for me. And then also there will be a warning in the programming code that division by 0, it is ineligible here, or it is invalid to divide by 0 in some programming languages. So this is part of the limitations of arithmetic inherent in programming languages. Or sometimes if you have loops, and these loops end up as an infinite loop, this will create an overflow, buffer overflow, that will be caused by this infinite loop, in which the memory cannot handle all this output displayed. Relational and Boolean expressions. What are the relational expression? Relational expression depend on relational operators like greater than or equal to, less than or equal to, equal to or not equal to. All these are operators. They deal with operands. So when we mix operators and operators, these relational operators with operands, it will end up in relational expressions. We call it relational expression, and the result of them are Boolean. Yani the result of this is Boolean, because it is going to be either true or false, because we use them in if statements or switch statements or loops. So the resultant of relational expressions are Boolean or logical. Sometimes operators are vary. All these highlighted here are considered in many different programming languages as what? As not equal to. This is 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 not equal to. But in different programming languages, in many programming languages that in many programming languages that we study, there will be operators that have different meanings. So also equal can be different in many programming languages. In JavaScript, for example, and PHP, they have two additional relational operators, which is triple equal to, or exclamation mark with double equal. They are similar to equal. This one is similar to equal. So we use it for testing for equality when we use them inside if statements or loops or something like that. This one is similar also to not equal to, like the one that we use here for non-equality, except that they do not coerce their operands. That means there is no the difference. Basically, I would say in this slide I have given you the difference between equal, double equal, and triple equal. So the difference is that equal here is used for assignment statement, which is assign a value to a variable. Double equal is used for testing for equality between two values, comparing two values. Triple equal also comparing two values, but the difference is that triple equal will also check the data type first, because some of the data type of the two values might be different. So it's going to check, are both values are integers, are both values are double, are both values can be compared, because sometimes people can compare a value to another that has no relation. Like this, for example, if 77, for example, greater than the letter A, small. So if you compare this one, or equal A, like that, 3 equals. So how do you evaluate this one? So this triple equal will compare the two values, 77 and A, but also will check the data type to see if this is actually an integer or a character or a double. So this one is found to be an integer, this one is a character. So for example, in C++ or C based languages, this will be converted to will be converted to 97. Why 97? Because 97 is the ASCII value for A. ASCII value, American Standard Code for Information Interchange character value for A. So this is fifth statement will end up to be false, because 77 is not equal to 97 after comparing the data type and taking it back to its ASCII value. The ASCII value for this, let me check it here, for example. ASCII code. Alright, I would like to check one of the tables that has ASCII character codes, like this one, for example. Look, A, small a equal, if you can see it, guys, A is 97 here. So this is just an example showing you that triple equal is like double equal, except the fact that it actually check the data type for the two values. And the relationship between relational expressions and Boolean expressions is that operands and Booleans, and the result is all Booleans. That means it's all logical. So you can actually, when you compare a value to another value, your result, it is either 1 or 0. It is either true or false. It is either yes or no. The C-based languages also will provide more characteristics which is allow for double check on relation expression, like this one, for example, A less than B less than C. Can I check three values together for using a relational operator less than, for example? Can I do that? Yes, I can do that. So how is it evaluated? It is evaluated from left to right. That means these two will be evaluated first. If the result is going to be true, then it will be assigned to number 1. True mean 1. Then number 1 will be compared to C. We see the value of C. What is it? If C is 5, for example, and this 1, then 1 is less than 5, then the result is true. I think I have an example here that that I can show you here. I have this C++ example in which I have three values, A, B, C. I have 4, 5, 6. I would like to see if A is less than B and B less than C. Is it true or false? So first we're going to compare A to B. Is A less than B? Yes, A less than B. So what is the result here? The result here is 1, number 1, because it's true. And then is 1 less than C? C is 6. So yes, 1 less than C because C is 6. And the result of this is 1. So the result is going to be true. See that? So yes, in this Boolean expression, we can have more than one traditional expression. We can have this expression which is legal, and the result will be just like what I have explained. Short circuit evaluation, on the other hand, is the one in which when you reach the part of it, you can get a result without the need to go to the second part of it. It means that when you evaluate the Boolean expression, you can stop as soon as you find the first condition that satisfies your condition. For example, if you would like to see if all of this is 0 or not. If, for example, A is 0, then there is no need to check this at all. Why? Because 13 multiplied by 0 is 0, and 0 multiplied by anything else is going to be 0. So the result of the whole thing is 0 because a here is 0. So there is no need to check this one. If there is no need to check the other part of the expression, this is called short circuit evaluation. Short circuit evaluation means when you evaluate part of the expression, this will satisfy your result. Also, using and or conditions. I think this one can be done using and using or in C++. So, for example, if you have like this, if, for example, let me change this program a little bit. If a less than c, or a or c is greater than 3. So in this example, this is if statement. I have or here, and I have two conditions, this condition and this condition. If this condition is correct, is right, then there is no need for this one, right? There is no need for this one, because my statement says if this is true, or if this is true, both of them will work. So what is the need for me to check the second of the expression? Now this one will work because a is less than b. So this has not been checked at all, because once it's fine a less than b, خلاص, that's it. 4 is less than 5. Then the result will be done without the need to go to the second part. That is called short circuit expression. Also, the only side effect when the second part of the expression experience any increment or decrement or compound expressions, then there might be some side effects and some problems might be expected in these expressions. Other than that, the short circuit evaluation, it makes your program straight, and it will make your code shorter, and it will actually reduce what's called the compiler time for checking all statements. Assignment statements. General syntax for assignment statement is that you assign a value to an expression. Assign a value or a variable to an expression. This is a variable. This is the assignment operator. So this is a target variable. The assign operator is equal sign always. The expression is what you find on the right hand side, like x plus z, for example. So this is the general syntax. However, this equal sign, sometimes it might be equal like that. Sometimes in some programming language, they might put like colon equal like that. In Ada, in PL/SQL, all this you can use colon equal instead of just equal. I have an example here in PL/SQL that I can show you, in which I have a program. I declared two variables, x and y, as numbers. Assign. Look at the assignment statement here. So the assignment statement colon equal, not just equal. Here colon equal. So this one's 3 plus 6 has been assigned to result as a number, and then it is being displayed. So this one will provide this result. So result is 9. If I just use equal like that, it will get an error. See, it is an error complaining about encounter this symbol. It doesn't know what this symbol is, because the symbol colon equal, it is the one that is expected for this program. The assignment statement sometimes can be used in the conditional statements like this. Instead of using if statement, I can use conditional target in Perl, for example, or in C or C++. I can do it like this, which is you use condition and then you use, after the condition, you use equal. I think I have an example for that conditional test here, where I have, for example, this expression. I don't have if statement, but I have this conditional test in which I would like to check to see if count equal to 0, then average is equal to 0. Otherwise, if it is not equal to 0, if count is not equal to 0, and here count is equal to 10, so count is not equal to 0. So this one is going to be executed. So sum will be divided by count. That means 40 will be divided by 10, and the result of average will be 4, right? So I am using equal here as an assignment statement. I'm using double equal here as a relational operator for this program. So this is the result of this program here. Because sum divided by count, 40 divided by 10, which is equal to 4. So here, this assignment statement is used to assign the whole condition to a variable. So this is part of the assignment statement features. Assignment statement can be also used in compound operators, like for example, A equal A plus B. This can be rewritten as A plus equal B. You know that, or can be or for example, A equal A minus B. This can be written as what? Can be written as A minus equal B. A minus equal B, or A equal A multiplied by B. This can be rewritten as rewritten as A multiplied by equal B, and so on. We can use it in division also, and modulus operator, and so on. So this is a shorthand method for specifying a commonly needed form of assignment in C, C++, in Java, in all these expressions. We call it compound. This one is called compound what? Compound operators. Unary operators is the one that you can use decrement or increment. Unary operators in C-based languages like C, C#, and C++, you combine increment and decrement operation with a single statement, assignment statement. So instead of count equal count plus 1, you can say count plus plus, or plus plus count, or count plus plus or plus plus count is the same, except that when you use count plus plus, that means count will be incremented, and then the value will be displayed as the same value, and until it is used in another statement. But if you use here, for example, plus plus count is incremented. Count is incremented, then assigned to sum. Yani you increment count first, then you assign it to sum. So if count is 5, then and you put plus plus count, then this one will become 6, and then assigned to sum. So the value of sum is gonna be 6. This one, count sum equal count plus plus. If count is 5, then 5 only will be assigned to sum. But the next statement that you use count, then count will be incremented by 1. So here in this one, count will be assigned to sum, then will be incremented. And it will assign count to sum, whatever the value was, then it will be incremented later. So this is the difference between, we call it pre-increment and post-increment. And when you use minus, we call it pre-decrement and post-decrement. Sometimes in C-based languages and Perl and JavaScript, the assignment statement will produce a result and can be used as an operand. So here, for example, look at this. The whole statement here, this whole statement, it is used as an assignment statement. So if ch equal this, so in this one, it is used as an operand. This get char, for example, is when it is carried out, the result will be assigned to ch. So the resultant of this function will be assigned to the ch, and then it will allow the while statement to work on them, to be processed on them. So the whole statement will be used as what? As a conditional value for the while statement. But what happens here, this one will be assigned to ch. The value of this one, get char, the value of this get char will be assigned to ch, and then it will see if ch is not equal to end of file, if you did not reach the end of the file. This is the readability is one of the side effects of this type of expression. Multiple assignment statement can be allowed also in some scripting language like Perl or Ruby and Lua, and also PHP. You can have multiple assignment statements like this. For example, you have three variables separated with commas between parentheses, equal three values separated with commas, and also between two parentheses. That means 20 will go for the first, 30 will go for the second, 40 will go for the third. You can do that, and also you can have an interchange like that. If you put first second equals second first, you're swapping the values. So now the first second equals second first, so the values of the first will be second and the value for the second will be first. So it can allow for interchange also. Multiple assignments can be multiple assignments like this, three values or more, though there is no limit of the number of the values. So if you have, like, for example, here fourth, okay, if you have another variable for fourth, and then you have to provide a value for this fourth here, otherwise this one will be assigned to 0. But if you'd like to assign it a value here, like for example 50, then you can have the value here, and so on. So the number of values should be equal to the number of variables declared between parentheses. Assignment in functional languages, in modeling language and also F#, the names are bound to the values with val. So we can have let or val. If you use val, means value fruit equal. So actually you use val, the value fruit equal apples plus orange. So in modeling language we use val for assignment. You have to specify the variable with the operator val. Value means value fruit equal apples plus orange. In F# and some other language you can use let. You can use let, like let fruit equal apples plus oranges. Apples plus oranges. So it will create a new scope or a new different way of assignment. Assignment statement can also be mixed in different language like Fortran, Perl. You can have different values mixed together. So you can assign any numeric type variable to any character value, to any floating point value. And as I told you before in this video, that you can actually add a character to a number. if you add a character to a number, then that character automatically in C-based language, this character will be converted implicitly to its value here, and then added to that integer value, and then it will be processed. And in Java and C Sharp and also C++, this will end up in what is called widening assignment coercions. That means the value is going to be either approximation of the value that has been assigned, or more or bigger than the value that has been assigned or processed. But in Ada there is no assignment coercions. That's it for this chapter, in which we did explain the expressions, operators, precedence, and associativity, and also we explained the operator overloading when you have operator is used for more than one purpose. And then we did talk about mixed type expressions and different types of assignment statements. This concludes chapter 7, in which I will put in week 12. And Assalamu alaikum wa rahmatullah.